Hey,
We got a bumper now.
so what happens when you hire a designer?
So fancy. Thank you, Tim. Tim made us a cool bumper. Welcome, everybody, back to the remix roadmap planning. Yes, the remix roadmap planning, not the React router roadmap planning, in case you were, I don't know, worried about that for some reason. We are still remixing it over here. How's your summer going, Ryan?
Man, when you got teenagers, it's like so busy. It just suddenly got so busy.
I was up in Utah.
When?
You know what for Pioneer Day?
Oh,
You know what I love about Utah that you just can't
when
do
your
here
friends
in
visit, they don't come say hi to you. Is that it?
Who doesn't come say hi to you?
You didn't. I didn't know you were here.
Oh no, I should have said. Yeah, no, I don't know. When I'm up in Utah, I'm just like, there's so.
I know.
We have like a schedule when we're in Utah. It's
Yeah.
like my wife's brother, my wife's sister, my wife's parents, my brother, like
My
people
business partner of 10 years.
that I see you like all the time. So
I'm just
anyway,
kidding.
don't
All right, what do you love
take it
about when you
personally.
visit
Don't take it
Utah?
personally.
What do you love about when you visit Utah?
Well, what I was gonna say is, you can get these really big fireworks.
Oh, that's new. That's not how it was when I was a kid.
Yeah, no, well, you used to be able to get them in California, but you can't get them in California anymore. But
We'd have to drive to Wyoming when I was a kid.
Wyoming.
Big crazy ones.
You have to drive to a state with a lower population than wherever you currently live.
No, it's literally
So the
Evanston,
restrictions kinda
Wyoming
loosen up.
is like just barely over the border from Utah. And so it's like you drive and you go 1 mile over the border and it's like fireworks stands everywhere.
Oh, that's awesome.
Yeah.
That's awesome. Yeah, so we went out there and I found a fireworks stand that was doing like buy one, get one.
Yeah.
And I bought so many fireworks and we launched them. It was awesome. It was fun.
I love doing that. And we do it by the lake up at Bear Lake, and we set out a big old plank, like a big plywood thing, and just line them all up and light them.
That's perfect.
2 years ago, we had one malfunction, and it like shot right at the house, like the porch. So we have this porch that overlooks the lake.
Oh,
and
wow.
The whole family, there's like 26 of us, and it shoots there, and they're like these spinner things too. So it's like going. It was the funniest. It was.
That's the thing with fireworks. You never know. You gotta be.
Gotta
be careful. Oh man.
Yeah, busy summer.
Cool. Well, we've been busy shipping some software too. We've been shipping all kinds of stuff. Let's talk a little bit about we've been calling it fogOfWar, but with so much war going on.
Let me pull up the release notes.
Yeah, I think we're just gonna call it lazy route discovery. But fogOfWar, just FYI, was a reference to a video game, not to actual war.
I guess we got some feedback from people where they're like, when you like translate this to other languages, it sort of sounded
a
little crazy.
Yeah. Well, how did Blizzard translate it to different languages? I don't know. Like, we should have done whatever they did.
Yeah, maybe in that context it made more sense.
Yeah.
We're like, fog of genocide, and they're like, what are these guys doing? Yeah, so we released 2.11 remix on the 1st of this month. So yeah, unstable fogOfWar is now lazy route discovery, and now you know what it is probably. And this is working out great. We've got it live on Shopify.com. A few other people using Remix have been using it, and it's great. So of course, our goal is always like, how do you have infinite scale? And our route manifest was gigantic in some cases, and so this allows you to have as many routes as you want. But we've covered that before. Yeah. This is what we covered in the last live stream, where you and I were kind of talking about this, and we realized, we don't need this response stub thing anymore. And so we worked all that out, and in 2.11, that thing's gone. Which it was unstable. It's all part of unstable single fetch. So I know a lot of people started to adopt that, and maybe that was partly our problem because we like documented it too well. Like we have a whole document on like how to adopt this. but it's unstable, and so that's what that means. We can change these APIs when they're unstable as much as we want, and you can't get mad at us. And we super appreciate when people do mess around with it, so that we can arrive at a better API. Yeah, so I guess the short version of this is single. I kept saying in our calls, Remix has always been single fetch.
Yeah.
For a document request.
Yeah. Yep.
Now it is single fetch for a client navigation.
Yeah.
And so it's actually less code in Remix itself and more deterministic behavior and fewer surprises.
Yeah. The way I kind of think about it is it was kind of like like, would it be fair to say it was like a premature optimization?
Yeah. Well, and
it turned out not to even to really be an optimization. Like it turned out to be something we didn't actually want.
Like most optimization attempts, it's just a matter of trade-offs.
Yeah.
Yeah, we were very into the nested routing, nested layout where I mean, it's on our homepage too. Like if you go to
Remix.run.
If you go here, I'm still really proud of this site. This was fun to build. Right here, where we're just kind of like really leaning into that, like, okay, this blue part of the URL is this layout, and it's got this data, and this one has this layout and this data, and this one has this layout and this data. And we were like, if only that layout is changing, if only that nested route, if only that portion of the URL is changing, let's only fetch that data.
Yeah.
Which is still what it does, even with single fetch. Or sorry, you can still do that if you want to a single fetch with unstable should revalidate. But now you can just do it both ways.
Sweet.
Yeah. So yeah, short story is now it's single fetch. It was always single fetch for document requests. Now it's always single fetch. Fewer surprises. We can do better optimizations on the server with like server-side caches. And we thought that we needed this response stub, but we don't. And with our new streaming format, we don't even need this JSON thing. Man, it's all so intertwined. People keep asking, when is React Router v7 coming out? Really, there's two things that are that we're working on for this, and it's the single fetch stuff that got a little bit more complicated than we expected because we did an optimization by default, and now trying to like unwind that to a simpler model is difficult to do the upgrade path, right? If we didn't have an upgrade path, if we just like did what we wanted to do now, we would have been done a long time ago. So it's hard to unwind an automatic optimization in a incremental way. And what we've really bumped into with that is the type hints and type inference. Because with our new streaming format, you can just return this naked object, and your use loader data can just know that, or really the new. Anyway, so we started looking at types, realized a whole bunch of things that we're going to have to do there, and it was like, oh, we're going to need a different kind of type, and then you're going to have to type your loader, and like it just got really complicated. And that's where create route showed up, or define route, I think is what we're calling it. And then once we have defined route, we realize there's a whole lot more type inference that we can do across your whole route module. And so it was one of those things where it's like one small change allows us to simplify a lot of things, but to build the backwards compatibility layer, it's complex. And then when we realized that we could do some type stuff, we want to do that right out of the gate.
Honestly, I think the backwards compatibility is the hardest part of this whole
It really is,
right? Because like the North Star, the destination, is actually this really simple, like it's beautifully simple. Like we're making a lot of simplifications, especially, I don't know if you guys have been following the work that Pedro has been doing with some of the type inference stuff for the routes. It's basically, Ryan called it define route, but Yeah, it's going to be really, really good, and we're going to have a lot more to say about that very soon, I feel like.
Yeah.
But anyway, there's just so much great work that has like spilled out of this one change, which was like, Ryan's original intuition, like we should do this thing called single fetch. And like all this stuff spilled out of it. But I mean, this was the original API that we wanted for loaders, right? Like I never actually wanted to return JSON. I just wanted to return data out of the loaders. Like early versions of Remix, you just returned objects out of the loader.
You can't return a PDF out of a loader and give it to your component. Like, what the heck does that mean?
Yeah.
And it's weird. You get this pile of responses. For your 3-4 loaders. And it's like, what do you do with all the
headers? We got to kind of a weird place, but this gets us back, I think, to a much simpler place, which I love.
Yeah, it's a lot simpler. It's still a little weird because we still have the headers export and stuff. But yeah, it'll get simpler. We are working so hard to simplify this stuff.
Well, it turns out simple is hard, right?
Yeah.
It's so hard. People are like, oh yeah, that's so easy. Like, no. Whenever I see something that's truly simple, I'm like, there are a lot of people who spend a lot of time getting it there.
It's like been going around Twitter. The
Raptor engine, the
Raptor engine, right?
My gosh, dude.
That's not what software does.
And did you see what he's saying about it? He's like, we completely got rid of the heat shield because we internalized everything.
Yeah.
And it's like, it weighs less. There's less stuff on it that can probably break. I mean, it's way more efficient, way more powerful. Anyway.
So yeah, the way I'm kind of a thing in my head too is like everyone knows at this point I'm a big believer in what React is doing with server components and server actions. But
there's a but there. Uh-oh.
But it requires just a dedication to simplicity. I think it unlocks a lot of simplicity for applications.
Yeah.
But for us, the implementers, we've got to figure out how to do it in a way that looks more like the last Raptor engine than the first one.
No, React is working on Raptor 3, right?
Yeah. And
like, how can we make we had no idea that people were, or we had no built-in support, right, for forms and submissions and revalidations and all this stuff, right, that they're now sort of adopting into React, and they're internalizing it. And so anyway, it's
and so that is to say, I want to make sure that that the stuff that our implementation is relying on, the foundation that it has, is also quite simple, so that we don't like put a mess on a mess. And it's impossible. You have to iterate. But I think the problem with software a lot of times is that we don't do that iteration to simplicity. We just keep doing the iterations to more acronyms and more features and more just whatever, right? So for us right now, we're definitely in like a remix snow leopard year. Is like, we're like, okay, this service stuff that React is doing now is super cool. It took most of our job, but we're going to try to simplify our own internals, and then we're also going to try to, so that can help us build a simpler model on top of it.
Dude, I can see it. I know you can too. There's like this beach that is it's off in the distance, and it's just like so beautifully simple and powerful.
And kudos to Hydrogen One and Next for plowing through all this. And Astro's got server actions now, and Solid has use server. Like, we're lucky that we can just kind of let them fumble around out there a little bit while we clean up our foundation. I think it's gonna be really good.
Good stuff.
Okay, so that's 2.11 pretty much, is just response stub is gone. Everything works like document requests always have. We have the headers export for both documents and client requests. And then fogOfWar is, I think, the next release. We can probably get rid of the unstable on this. We have one open question on that. And so everything that's kind of holding back the Router v7 release is this single fetch stuff. We want that to be really good. It's the foundation for middleware and server context and server components and actual type safety. And then the second thing that's holding us up is type safety and hints on routes, and that's something that Pedro has been working on with define route and getting all that type inference. TypeScript is also a hard thing, like type inference. There's TypeScript that's like just, you give your types and then it knows that it's a string. And then there's like TypeScript where it's like it knows exactly what kind of strings, like specific strings. And with a 10-year-old project like React Router, it didn't start as TypeScript, and people weren't doing this super like specific type inference. But that's kind of an expectation now, and that's hard to bolt on to later, as you and I have found.
Yeah.
But we're doing it. It's gonna take some tricks and stuff that aren't exactly the way we'd like to do it, but we don't want to change APIs too much. And but those are two big things: a better foundation with single fetch, and then all the type stuff. Because the first time people use React Router v7, I just want them to be like, oh heck yes, I'm glad I stuck with these guys. I'm glad I'm still using this. I don't want it to feel like just a tiny step that then still has a lot of things that people are at, that is still missing a lot of things people are asking for, like all that type stuff. I want your first experience with an alpha release to just be like, this is awesome. So those are two big things holding us up. But I think we're almost there. We're getting close.
Yeah, it feels like we're getting close.
Here's changelog for React Router. Just some small stuff. You can redirect in loaders, but sometimes you want to redirect but replace the current URL. And so we have a new replace in there. And then we have this new data API. We've been bike shedding what to call this. Data is such a terrible generic name, but basically, I guess I need. You laughing?
Well, I mean, is it like when you say data, I think of Star Trek, right? Data. That's data.
Yeah.
Is it data is kind of what this is.
Yeah, so you can be like, sure, notes. I don't know where it came up with that. I would expect beef, but whatever. Oh, because my.
Oh wait, I can't see your typing. I'm still looking at your web browser.
What? I said share my whole screen.
Yeah, maybe try.
Let me do it again. We're using a new fancy thing.
Doing it differently.
Oh, window. I want entire screen. Here we go. Entire screen. Boop.
Yeah, there it is. That looks good.
Okay. So with single fetch, you're over here saying, hey, here's my loader. It's going to return that stuff. And you can do this today too. We have this thing called defer, and that lets you pass a response in here, right? Like status and stuff like that. Like, oh, this is a 404. I couldn't find like await get note or something, right? And then you're like, if I don't have a note, then why am I typing on my laptop keyboard and reaching all weird? Otherwise you return the note, right? This kind of a thing. Like you want to say, I guess before we had JSON actually. And that's how you would do a 404, but still send some data down to your component. Or do like a 400 with some like validation errors. That's actually better. Validate request or whatever, right? Data errors. I don't know. Lots of people have an API that kind of looks like that. And then you could be like, oh, if I got some errors, I want to return those errors to my UI, so then I can display some validation errors next to it, right?
Totally.
And with single fetch, where you just return raw data most of the time, there's no way to send those response headers. And that's where the response in it was coming from, where we're going to say, okay, you can set the
response stub thing.
Yeah, the response stub. You could say, oh, it's a 400, but just getting rid of that. We don't need that. But if you want to change the status, then
we'll give you a way to do that.
That's what the data function is for. It's just you're still just returning the data, but we want a second argument so you can add headers, change the status, etc. And so this will make it really easy with single fetch, as you can just run around and change JSON to data and get all your type stuff. You can still use JSON. You're just not going to get the correct types. When you can turn on single fetch, your code should be able to still just run the way it used to. And the behavior of the fetching changes, of course, though. But right here, depending on what your data is in this first argument, your type inference will probably be wrong. So you switch it to data, and type inference will then be correct. But if you don't have, if your code just looked like this, you just don't even need data or anything. You just return it. And so that's what this API is for. And you don't need defer either. So defer will go away. Our new streaming format just knows. It just knows inside of here that if you've got like some kind of thing, and this get thing returns a promise, you don't need defer. It just knows, oh, that's a promise. I know how to serialize that and deserialize it. So again, your code should all look a whole lot simpler. And that's kind of it. Yeah, we're doing a lot of work on just getting the single fetch stuff to work, the type inference to work, and then the route, define route API and all the type inference there, and build errors, so that if you name a file wrong and ask for a param that isn't there, then like it'll tell you, hey, that param.uid doesn't exist.
Totally.
So yeah, should be good stuff.
Cool, man. Cool. So let's talk about some of the stuff. That. Well, actually, are we good talking about the next stuff that we want to talk about, or can we move on, or do we want to?
Yeah, man.
Okay.
I'm good.
Yeah. So let's talk about some of the stuff I've been working on. So, I guess what's the best way to start this? I
have an intro for it.
Yeah, go for it. I'm struggling, clearly.
The React 19, we said this before, React 19 kind of took our job. And so Remix has had a little bit of a identity crisis. And so now that React has form actions and transition states and action states and revalidation and all this kind of stuff, what is Remix? And people have heard about this reverb thing, and what's Router v7. All of the server component stuff requires backend implementation. And we can either hide all of that and just give you a top level API like loaders and actions and Remix today. Or we can work on a set of primitives that we're going to use to implement server components and server actions. But they're probably going to be awesome enough that you just want to use them as like day-to-day APIs as well. And I think that's what you've been working on with these packages you want to show us. Michael's got a couple of packages that he's published. Node has been successful, and it has some nice APIs for HTTP and streaming and responses and requests. The Remix philosophy has always been, let's try to make this thing work wherever JavaScript works. And so that's the web fetch API and the winter CG stuff. And so let's build, as the bottom layer of Remix going into the future, let's build primitives, not necessarily like attached to Remix at all, on just this web fetch API for servers and clients over the network. And it's a huge hole in Remix today that we want to fill anyway. But let's build an incredible foundation for everything else that we're going to do over the network.
Totally.
How'd I do?
Yeah, no, that was a great intro. That was a great description of what we're doing. So yeah, I mean, just to kind of say it the way that I, one point I guess that I would like to add is, Remix has always been really inspired on the back end and on the front end, but inspired by web standards, right? And when I saw what they were doing with Cloudflare workers, how they were just using like the service worker API to make a Cloudflare worker, they had a fetch handler there. That really blew my mind. And I started thinking, service workers are servers.
Yeah.
And then, of course, the Undici project has done an amazing job at getting a lot of the fetch primitives working on Node.js. You look at any new JavaScript runtime, Dino, Bun, Cloudflare workers, or Workerd, and they're all just, sorry?
Node 20.
Yeah. No, exactly. Yeah, Node now, even with the Undici project, they're all just building on the web primitives. So, the existing sort of Node HTTP primitives have been around for a long, long time, and they've been highly optimized, especially when it comes to like the streaming and the support around that whole ecosystem, right? If you need to do file uploads, like you've got lots of good packages for doing that with Node's built-in streaming APIs. You need to do sessions or whatever, right? Or middleware, whatever. You've got Express, stuff like that.
And even with LLMs hitting the scene, like you really want to stream responses back down too.
Yeah, totally.
Streaming is a lot bigger than just suspense box spinners now. It's
totally
kind of critical part of any future app, it seems.
So I guess it's like you said, like future Remix is going to be much more sort of back end focused than, I mean, we do have good support for the back end now, but there's just a lot of stuff I think that needs to be done on the back end to really make Remix feel very mature for a back end developer workflow for a lot of the things that they need to do. So anyway, that's kind of some of the stuff that I've been working on. So I published 2 libraries in the last month. One of them is just this silly little headers library. I call it silly, but I'm actually kind of in love with it. I do a lot of work.
You're on vacation working on it. That says a lot.
I was, yeah. I do a lot of work with HTTP headers. I'm sure you all do. We do a lot of work with HTTP headers. And, the web and the fetch API basically gives you this headers interface, right? The headers interface we all know and love. Let's take a look here. So,
bump your font up just a little bit. It's kind of small.
Sure. How's that?
That's good. Yeah, that's good.
I could actually hide my thing too. Okay, yeah. So what can you do with headers, right? You can say, let's add a header, sure. So here's my string header, and then I can log it back out. Get my application JSON back out. So here I'm dealing with a header. Here's my header name. Here's my header value. Pretty basic stuff. What if I wanted to add like a char set to this content type, right? Because content, just to indicate that the encoding of the characters in the content, right? So I could go in here to this string and I could say char set UTF-8, right? Everybody's done that. Char set UTF-8. And now this string here will be the string, char set UTF-8.
Mm-hmm.
Car set. Some people say it with a hard C. Okay, so notice what you've done though is, you've essentially encoded like 2 kind of distinct pieces of information in the single HTTP header in this string API. And this is fine. Like HTTP headers have sort of evolved over time in this way. And typically what you do is if you have multiple pieces of information in a single header, you separate them with a little semicolon and off you go. And so you've probably, if you've done any work with HTTP headers, either you've been a little sloppy about it, or you've like tried to get really good and like get a, you've tried to like parse this string and figure out, what is in this HTTP header. So let me ask you, if you if you know, wanted to know what is the character set of my content, like what is the what is it, right? So I would say you know, I guess headers dot get content type. That should do it, right? Yeah. I mean,
For this one, yeah.
Copilot knows what I'm trying to do, right? Yeah.
Yeah.
So that'll split the string on the semicolon, and it'll give me the first one, and then it'll trim it down, and then so that'll give me this. That should give me this string right here, and then I might do like a, you know, dot replace. I mean, you could do it. You could do it cleaner than that, but that'll basically give you like the string UTF-8.
And there's so many like potential issues with that line of code. I mean, it all starts with that question mark. I might not even have a content.
Yeah, exactly. You look at that code and you're like, but I mean, this code exists in the wild like all the time, like everywhere, right?
I set the header. I know that's the order of things. I know it's there.
Yeah.
I don't care.
Or what happens most of the time is developers like put their head in the sand and like just assume that everything is UTF-8. And right, like I'm not even going to try and parse that out. I'm not even going to try and like deal with it because like who knows what, you know, like I'm not even going to worry about that. So, you know, so the question is, you know, can we get a better, you know, API for stuff like this? I mean, and content type is just like, it really is just the tip of the iceberg when it comes to the wealth of information that you get in the headers of an HTTP request. I mean, it's an integral part of the protocol. And the headers interface that we have right now is just kind of like it's kind of a blunt tool. It's basically just a bag for these strings, and you get and set the strings, you know, as needed. So so that
like cookie strings.
Yeah. Oh, exactly. Yeah. Let's talk about cookie. Yeah. Yeah. So name value, right?
Simple.
Yeah. Nice and simple. So, or actually, let's talk about set cookie. This guy's the real. Set cookie is the real weasel. Is the real weasel for a number of reasons. But anyway, so let's say we've got set cookie header, and then you know, you want to restrict kind of like the domain or the path that this cookie is on.
Ooh.
Yeah, there you go. So that's actually a good example of you know, the wealth of information that you have in a set cookie header, right? Like there's a lot of stuff here, right? Just put it on this domain, only set this cookie at this path, make sure that we only send it over HTTPS, don't let JavaScript access this cookie. And it's basically all encoded just in this single string here, right? So, you know, what if you wanted to know like what are the values basically out of there? You want to like parse that out, or you didn't want to like program it with a string like this, right? So anyway, I'm really bearing the lead here. So let me back out a little bit and let me get into this headers library and kind of show you what kind of things you can do with that. So some of you might have seen. It was like about a month ago, maybe I published this library called Fetch Super Headers. That was such a long name. I'm just calling it headers now. It's under my scope, but hopefully my goal is to just publish it as like the headers package on NPM. Okay. So what can you do with headers? So notice that you can do all the exact same things that you can do with the normal headers object. So headers are a subclass of the DOM headers that you're used to, right?
Drop-in replacement.
Yeah, drop-in replacement, right? But you know, you can do some other kinds of cool things, right? So this headers, you know, append could have also been a set. We can also set it like this. Headers dot, you know, content type equals application JSON. So you could set it to a string. But if you've got these, and of course,
so that's new API. That's API from mjackson headers.
Yeah, exactly. Yeah. Sorry. Yeah, you can't do this with the normal headers. If you take this out, it's going to be like, what is that property? Yeah. I don't know what property you're talking about there. So basically you've got getters and setters for all of the different headers. So headers.content type will give you a content type instance. And the thing is, all of these instances are stringifiable, right? So you can say, so you can still say headers get content type, and that'll still give you a string. And if you use this getter and you just like include it in like a string context.
Yeah, JavaScript will call toString on that if you're trying to coerce it to a string.
Yeah,
and it'll
exactly
still be the correct thing in there.
So that works fine. That'll give you that string just as well. Okay. So just to kind of,
and if that sounds like magic, you should go look at the source code of mjackson headers and see how that's pulled off. It's actually really simple.
Yeah, it's not bad at all. Basically, every header class has a toString value.
Yeah,
so every header class
is the thing that I think a lot of people might not know about. Any object can have a toString, and then that's
totally,
that's the rule.
Totally. So we can put our character set in it like that, and still use the sort of string API. But we can also actually do a little bit better than that, right? Let's say for example that like I have a function that, well, I'll show you some better stuff later on. So this is actually calling this the media type. And this is going to be the char set. And you've got types for all this stuff, right? So char set UTF-8.
That's awesome.
So you can just, it doesn't take too much imagination to think like, what if I had like a function where like I already knew this piece and this piece was the only unique piece, and I was passing that in as a variable, but I wanted to set the whole thing. You can work with these headers in like an object-oriented way. So the way I was thinking about this is this library for HTTP headers is kind of like the DOM API for an HTML document, right? HTML document contains a wealth of information, but it's just a string. And then you put it in the browser, and now you have all these objects and elements and things that you can read and do, right? So this library is basically that for headers.
I want to call out here really quickly how cool this is, that sometimes people will look at the headers API and be like, oh man, this API is a little rough. Everything's just strings. I'm going to want to parse stuff. And they might come up with the API you've got here on lines 8 through 10. They might think like, oh, this is a much more friendly API. But they might implement that in a way that isn't still just a subset of headers, right? They might implement that in a way that it's not composable with the standard web fetch API.
Right.
And be like, oh, well, our loaders return these types of headers, right? We could have done that in Remix. So you return headers that look like this, and then underneath the hood, we're going to turn them into real headers.
Yeah. No, these are actual headers, right? You can have a fetch request right here.
Yeah.
And you can be like, boom.
And that's why this is so cool, because you get the nice, convenient type API without bailing on the standards. So I know some people might look at this and be like, oh, I thought that you guys believed in standards. It's like, yeah. And this is still built on standard APIs. We just didn't hide it.
Yeah, this is extending the standard.
I love it.
Yeah, so you can use this thing anywhere that you use a normal headers, because it is literally a subclass. As we said, it works as a normal headers object. In fact, you can, once you get the response back from, you can actually, you can oh well
yeah
you can instantiate a new one with an existing like DOM headers object that you get back from a fetch super easily, and just like you can with a regular headers constructor, and you'll get all the types and everything from it. So basically anywhere you use a normal headers object, you can use this thing.
So cool.
Yeah, so thank you for making that point. It's just
a little bit of a
departure.
The hardest part of building libraries and frameworks is like How do you not just hide everything underneath a convenient API?
Yeah.
Because that's the trick to making something composable and something that's going to last a long time. Is not just hiding it all.
So, let's say that we're not even setting it like this. Let's say that we're just setting it like this, or that somebody gave us a normal headers object that's just set like that. So we can actually access headers.content type dot, and then you've got all your types here, right? So give me the media type, give me the char set, and then the other one that you've got in the content type is you've got boundary. So that's,
and you can still just access headers.content type as a string, right?
Yes, exactly.
Like before,
yeah. So you can, this thing composes like crazy. So you can say, give me the headers.content type.
Yeah, and even though it's got an object with all those things hanging off of it, its toString is going to give you the whole thing.
Yeah. So you could say like, if you are building up your own, like header string, you can just do it like that.
Sorry, you were going off on boundaries and I interrupted you.
Well, no. I was just saying you can access basically all of the properties of the content type, in this object sort of style, right? So in this way, you can see that this library it's a parser and a stringifier, basically, for all the HTTP headers, parsers and stringifiers, all up and down the whole chain. So let's take a look at so the reason I'm so excited about this is again, like we said, we're going to be kind of focusing a little bit more on kind of beefing up our back end. But this is, if you're working with Remix today, or if you're working with React Router today, or even if you're not working with Remix, if you're just building an app on Bun,
or a Cloudflare,
and you've got these request and response primitives, right? You can pull in this library today, and you can just immediately start using it and being productive with it. We actually, we've seen other frameworks and this is totally fine, right? Remix is MIT licensed, but we've seen some other frameworks grab pieces of our source code.
Yeah.
And basically just put it in their framework and be like, that's really good code. It's MIT licensed. I want to put it in my framework. Totally cool, right?
Just remember to bring the license along with it.
Yeah. Just remember to bring the license. But it really made me think, at least, maybe we don't have small enough chunks for people to use, right? Because they don't, the solid start folks don't want, they don't want Remix as a dependency of solid start.
But they wanted the cookie abstraction that we have there, which has nothing to do with Remix.
Cookies and sessions, right? Exactly.
Yeah.
So part of this work is just let's publish smaller packages. Let's publish a headers package. And then, TanStack will use it, or Astro could use it, or Svelte could use it, or whoever could use it. Anybody that's building on the web fetch primitives, the whole ecosystem can totally use this package without depending on Remix, and take advantage of it. So as you can imagine, this stuff goes away. This kind of code goes away in your code base. Also, let's just take a quick look at set cookie, and then we'll move on to the other library that I've been working on. But this is like I said, I've been at first I was like, I don't know if this library is actually good, but the more I've been playing with it, the more I'm like, I actually love this thing.
I don't know if this is good.
I was really kind of hesitant to be like, I don't know if I'll, I don't know if I'll actually. Okay, yeah. So it's completing it for me. It's name, value, domain, path, security.
Who are the people in your head where you're like, I don't know if so and so would even be interested in this?
Oh, well, it's other framework library authors.
Yeah.
Oh, interesting. Yeah. So I don't know.
I always have people in my head when I'm making a thing, and I'm like,
there was some initial feedback that I got when I first published it, where somebody was like, "That's a bad API." Like it was that Artem guy. He was like, that's a bad API. And I was like, why do you think it's a bad API? And I think what he was thinking of is kind of the concern that you addressed earlier, like you're overriding global. Like that's a terrible idea.
Yeah.
Don't override the globals. Don't confuse the globals in people's minds, right?
Yeah.
Which is why I originally gave this thing the name like super headers. You know,
Yeah.
it's not like you don't have to override the global. And to be clear, like you can totally still do that. You know, the call them the fancy headers. You know, the fancy headers, I get them from somewhere else. You know, I'm not gonna overwrite my headers. You know, I love that interface, Michael. I love the strings interface. So don't
I'm having
overwrite.
Copilot write my parser for me.
Yeah, it's like, okay, fine. Don't just import it as something else, right? But the
Mhm.
more that I use it, the more I'm just like, my gosh, dude, I don't ever want to use anything else. Like I just want to use this. And
Yeah.
if it, like we already said, if it works everywhere that normal headers works, like why the heck not?
Yeah. And until you wrap it, TypeScript's not going to lie to you too.
Yeah, exactly. Yeah. Yeah, exactly. Yeah. Yeah. If you call this something else, yeah, now TypeScript is upset about all these things that you're doing, which you can't do on a normal headers object.
When I mean the headers that come back from that fetch on the response.headers.
Oh, yeah. This thing.
Yeah.
Yeah.
The response.headers right now doesn't have all the fancy stuff.
Yeah. This is
So there's really no
your
concern.
global this dot headers. Like we're not clobbering that. I'm not getting all up in your fetch, right? Like you just do whatever you want. And if you want a nicer interface to access the stuff that's there. Yeah, we already showed this.
Yeah. Now you wrap it, now you get.
Now you're cooking with gas, man.
Yeah.
Now you're really rocking and rolling.
I love it.
So this is some stuff. I just briefly showed the set cookie stuff down here, which is you basically can set cookies as objects. I mean it basically works exactly as I would hope you would expect an API like this to work, right? And if you need to set multiple cookies, you've got an array there. So,
now how much does this overlap with our current cookie abstraction in Remix? Because it's got like the parse and serialize and.
Yeah, I mean, there's definitely some code that we can simplify in Remix when we include this stuff. There's definitely some code that we can simplify in Remix because we're doing some parsing and
for the secrets. I remember the secrets we used the web crypto API, and then that turned our cookie abstraction into an async. So you have to await cookie parse for the secrets. So do you anticipate we're gonna add that kind of stuff into the headers package, or do you think we're still going to have that extra cookie abstraction on top to deal with signing cookies and stuff?
I mean, we're still going to have. I think we're still going to have. There's still some more work here to do for sessions, right?
Yeah.
Like this is just at the very bottom level.
Yeah, very
I need to set a cookie, set these values, right? But like we're not going to include like signing or anything in here, right?
Yeah. So if you want to do some signing and stuff, it would just be your own secrets, and then actually, I guess you'd have to. Never mind. Yeah, that's a totally different spot. Okay, cool.
Some people in the live stream are asking if you can like push into this thing. Yeah, you can push into it.
Yeah, it's just an array. Of course, if you stringify it before you push, you're not going to have the latest stuff on it.
Yeah, but go for it. Okay, cool. So
love it.
That's headers. So have fun with your headers and yeah, good. So the other library that I've been working on is for doing file uploads. So let me switch to that one real quick.
Alex S. Fonseca just said, I'm worried about the fate of Remix. I use it in almost all my projects, and I'm afraid it will end. We're still building routers.
What do you think we're doing here, bro?
It's been a decade. Like, look how old we are now. Go look up some of our old talks and look how little we were.
We're literally working on it right now.
I got a Remix glowing sign that I still need to hang on the wall. You got to put yours back up.
Yeah.
It's not going anywhere.
Well, also, like, yeah, Remix. Like, we literally just talked about how Remix is being dog fooded at a $100 billion company. Like, I feel like web developers like don't get the business side of things sometimes. You know, they're like, I would rather. I'm gonna say something I regret.
All right, just show us your form.
Like I would rather trust a company with no real revenue model and a VC funding before I would trust like an actual profitable company to build the infrastructure that I build my business on.
Especially when we have the history of 10 years of being just a couple of dudes supporting our own work, and now we have this big company behind us. It's like we've been here the whole. We still ship releases to React Router v5 and v3 probably. Yeah. So anyway, yeah. Appreciate the question. It's not an invalid question, but
no, it's
yeah, here we are.
I will be here to hold you as you in your insecurities. You can come into my warm embrace, and we will ride this wave together. It will be fine. Okay. Multi-part parser. This one I'm actually like super freaking pumped about. Well, like I'm pumped about both of them, but this one's actually a lot of fun.
I mean, we've had unstable upload handler.
Oh yeah, F that, dude.
The beginning.
No, F that.
And it's because we didn't have this. Like,
yeah, F that.
And nobody has this.
Yeah, nobody has this. This has
been missing for ever since Fetch showed up.
Yeah. This has been missing. This has been missing big time from the ecosystem. So multi-part parser. Some people might look at this and be like, I know exactly what that is because I know what multi-parts are and I know what multi-part parsers do. Other people might look at it and be like, what the heck is a multi-part? So a multi-part request is, let's say in your, let me just make a new file somewhere. Okay. In your web page, you've got a form that does one of these, right? What the heck?
You're in a TS.
Oh, a TS file. MD.
It's
yeah. So you're basically just you're doing HTML stuff. You're uploading files, right? You might have seen a form like this at some point, and somebody was like, "Oh yeah, if you want to upload files, you need to put this thing in your form, and then it'll work." Well, what the heck does that even do? That sends a completely different type of request to the server, right? Now it is encoded in this weird format.
And if you're using Next.js with the app router and form actions with server actions, you didn't write enc type multi-part form data, but the framework did for you. So this is like a very foundational piece of React 19.
Yeah. This is just HTML. Regardless of what abstraction you're using on top of HTML, if you want to submit a file and a form, with files, uploads, and things like that in it to your server, ultimately somebody's making one of these.
Yeah.
So whether it's Next or whatever is making one of these. Okay, so then the question is, well, when that request hits the server, like, what does it look like? How's that request handled? So the short answer, oh crap, we're like running out of time. The short answer is the request is, you can look up what a multi-part request looks like, a multi-part format. It's this big long string, and it's like delineated by this boundary that's just a random string of characters that the browser creates. But ultimately, like, these files can be really huge, and you're handling uploads.
I wouldn't worry about the time, man. Just tell your story.
Just tell the story. All right. Speak my truth. Is that what you said? Okay, so and there's a lot of other stuff you can do with multipart as well, right? So file uploads is literally just the beginning. Multipart content is used in all sorts of stuff. Like it's used a lot in email. Like imagine an email where you've got a plain text version and you've got a text HTML version, right? Like that's a multipart document. That email is part text and it's part HTML. So that's a multipart mixed message. And then it's used for like attaching email attachments, right? Like you attached a file to your email. How does that look at the protocol level, right?
Yeah. If you're building an email client, how do you know it has an attachment?
Just a big old string of characters in the email message that is a multipart message. So, so this is actually really, really useful to have a nice fast parser. Especially important to have a parser that that can handle really large payloads really quickly. So when Node.js came on the scene a long time ago, everybody was really excited because Node.js was non-blocking I/O, and it had the streams abstraction. So like it was never buffering anything. And if somebody was uploading a large file, well, you would just like stream the thing to the file system and you would use very little memory. The reason we're streaming is because we don't want to, if somebody uploads 100 megabyte file to my server, I don't want to shove that whole thing into memory and be like, okay, I'm getting data. Memory is increasing. Okay, now I've got the file. Now what do I do with it? I'll save it to disk or I'll put it in S3 or whatever, right? You don't want to buffer all of that data.
Yeah.
You got to have a streaming interface so you can say like, and sorry, I know you know this. I'm just saying this for the viewer.
No, it's great. I'm just nodding and staying engaged, keeping everyone else engaged.
So yeah, so you want a streaming interface. You want it to be nice and fast. You want it to be good for big stuff. So anyway, multipart parser. Why multipart parser? So a lot of the multipart handling that has been done in the last, in the JavaScript ecosystem in the last, decade or so has been specific to Node, right? Which is.
I just thought of an analogy. I was thinking of an analogy when you're like, I know you know this.
Oh, what?
When you need to water your lawn,
yeah,
you don't get all of the water that you need into one giant hot tub sized container and then dump it on your grass. They'll actually like flood things and cause problems. You stream it. It just comes out of the sprinklers over time.
Ah, yeah. I like that.
And so when you're uploading something to the server or sending something down, you don't fill up that buffer and take up 100 megabytes of memory. You just process each part as you need to.
Yeah, totally. That's a great analogy. That's a great analogy. I'm going to switch back to TypeScript so I can get some types in this code. I'll just say this is the HTML that you wrote in your web page, right? You've got some HTML. So what we can do is we can say, okay, so what are we doing? So what is on our server side? And Remix actually gives you these things called requests, right? So let's say you're writing like a Remix loader. And the request comes in here, right? We've all written one of these things. What is this thing? This thing is a request. Right? You might have looked at this interface and thought like, oh, it's a fetch API interface. It's a request. That's cool. What stuff does it have on it? Well, the request has a cool little property called request.body, right? Request.body is a readable stream of data. So this is just a raw stream of the bytes that are coming across the wire in this request. I don't know what's there. Like most people are just going to be like, hey, like, give me the text.
Yeah.
Like just buffer the whole thing. And you've done this with your, you've done this like with your responses, right? Lots of people will do, because request and response essentially have the same construct where, you've done like a fetch. And you'll do some fetch, and then people are very familiar with this. like await response.json, right? So basically what you're saying when you're
That's
saying,
all I knew until I started using Remix.
totally. Yeah. When you're saying await, you're basically saying, hey, response object, take your whole body, your response.body, buffer that thing. And usually, in a JSON payload, it's not too big. It's not like a massive file or something. So it's not a big deal to say await response.json, buffer it, parse it as JSON, give me the JSON, right? Like that's something that people do all the time. So, if people were sending JSON requests to your server, which they're probably not doing, but you could await request.json. That's totally a thing, right? The browser the browser also gives you, and some people have probably wanted to do something like this, right? Await request.form data.
Yeah, it's Remix actions all the time.
Yeah, I mean, that's what the browser told me. That's what you told me you were giving me, right? You told me you were giving me form data. Okay, give me the form data. The only problem with this API is it's very immature on JavaScript servers right now. Typically, what you'll get is like the thing is it just varies based on the implementation that you're using. I think Undici, which is the one that comes built into Node, I think will. I think it just buffers the whole request. Somebody please check me on that.
Yeah.
I think it'll just buffer the whole request. And then, so if you have 100 megabyte file in here, and now you can say like form data.get file, right? If you had a file in this form that was like that. I think that on the server, I think that you would actually just get like a file object that, that is sitting there in memory that is quite large.
Yeah.
Either that or it won't work at all. So some of the people will give you like form data polyfills and they just don't they either just kind of punt on this problem or they just buffer the whole thing and give it to you in memory. So we've already talked about why we don't want to do it all in memory. A nicer way to do this would be if we had a streaming parser. So let's get this thing and let's call, you can actually import request, parse multipart request. So parse multipart request, it comes from multipart-parser. It's basically this thing. So you can say for await, let part of parse multipart request. Okay, so we're not gonna buffer the whole thing. We're just gonna parse it on the fly. Thank you, Copilot, for spitting out my whole API here. So, so you can actually you can grab these parts from the request. So parse multipart request, what is it going to do? It's going to read the request.body, that readable stream. It's going to read it and parse the bytes as they come flying through as quickly as possible. And then this await means wait for the next part to come flying out of there. Wait for the next part to come flying out of the stream. Okay. Once we get it, we can do some async work here, right? So the part is actually a multi-part, but it's got some cool stuff on it, right? So let's say, you did upload a file to your server. So the name is just going to be the name of the input field. The file name is going to be like the name of the file that was uploaded, right?
That's good information. The operating system gave to the browser, and then the browser sends that up.
Exactly. So you might actually be interested to know that, these parts have
their own headers.
Parts actually have headers to them. Like if you look at the raw sort of, and I wish I could probably do it. You don't even need to show you that. If you look at the raw multipart data, each part of a multipart message has its own little headers with it. And those headers contain things like the file name and the content type for that part, right? And the actual name of that part. So you can actually just access the raw headers of that part and give it to me, but you most likely just want kind of these properties here if you're saving the file somewhere. You can await part.text, right? Await part.text, or part.bytes. We'll give you the raw bytes. So this is this will give you an 8 array. But most likely you're not actually going to want to like just buffer that thing here. Most likely you're going to want to like put it somewhere else. So let me actually get out of the, yeah, Colin Miller, everybody's getting ahead of me. Colin Miller says, is it possible to stream the bytes of a part? Each part could be large. Yes, indeed, sir. It is possible to stream the bytes of a part. So let me get into some examples that I built. So I built examples for all of the major JavaScript runtimes. So I've got working examples here for Bun, Cloudflare Workers, Dino, and Node. So Dino actually has a really nice streaming API. I was talking to Ryan Dahl about this actually. So here's a fully functioning Dino server. Actually, let's just boot this thing. No, because then I'm gonna have to like show you. You can boot it. It's just
we believe you.
Yeah, you boot this thing. You'll serve up a document that looks like that. When the request comes in, we're going to use the parser and we're going to say, look, if it's a file, it's got this is file Boolean thing on it. Makes your job easy. Create a temp file and then write that part. Each part has a body, right? So the request has a body that is a stream.
Mm-hmm.
Each part also has a body that is also a stream.
That's why it's multi-part. That's how you have attachments.
Exactly. So you don't got to buffer that thing. Dino's got a really nice API to say, hey, go and write this file, and it accepts a stream as the second argument. So go and write that stream to that file. So you don't ever have to buffer anything. You don't have to, you don't have to buffer the original request, and you don't have to buffer each part individually. It streams all the way down. Streams all the way down.
I built a side note. I built a photo review. My wife is a photographer and had a business before my career was established very well. And one of the first apps I built, I allowed her through Flash, because that was the only way to upload files back then, to upload like huge images from her camera.
Yeah.
And
they can get so big.
And I was doing it all in PHP, and it wasn't, I had no clue about hardly any of this stuff. It's kind of when I started to learn it. And I was crashing my little shared hosting thing all the time.
Totally. Because it was probably trying to buffer the whole image.
Yeah.
You know, everybody hates buffering. It's what you see on the TV when you like see that spinner and you're trying to watch Netflix, and it's like, oh gosh, I'm buffering again.
Oh yeah, it's such an easy concept. It's that like the YouTube play bar at the bottom shows how much it's buffered and how much you've watched.
Totally.
So you want that to be pretty small on your server, because that's your memory on the server. If it gets big, then you might crash it.
Yeah.
Especially with serverless stuff.
Totally. Everybody hates buffering. We're not buffering. We're not doing any buffering. So Dino's got a really nice API, but if you want to check out how it works on the other runtimes, Bun also has a pretty good API for this. With Bun, I made my own little wrapper function to deal with the stream. So I said write file, and basically this thing takes a Bun file and grabs the readable stream and just writes the bytes to the file. They have this file.writer API, which is a writable thing. So you can say, like, as each chunk comes flying off the stream for that part, you can say writer.write that chunk of binary data. So that's a decent streaming API. Cloudflare Workers, the Cloudflare Workers example is actually pretty cool because it uploads things into R2.
R2, nice.
Stores it in R2. The Node server is probably the one where I had to do the most work. I just created a write file helper here as well. Actually, similar amount of work to what I did on Bun.
You know how, I mean, you and I have talked about file uploading for years, and I'm always like, most of the time, you're just going to send it directly to R2 or directly to AWS or whatever, straight from the browser, right? Like, I don't actually want to do this on my server.
Yeah.
But I've been goofing around with a little toy app, and it's using an LLM and some other AI stuff with graphics, where I want to be able to upload something and have it analyze that image, right?
Mm-hmm.
That's not, like, even if I uploaded that straight to R2, now I've got to pull it from R2 to then read it on my server, right? And so there are cases where you don't even want to store the file. You just want to, you might just want to process it and not even put it anywhere. Like, you just want to look at the bytes in there.
Yeah.
And then hand it off to some.
Or maybe you want to manipulate the bytes on the way through and add a watermark.
Yeah. Yeah, yeah,
right?
yeah, totally.
Like maybe you want to put it through your own streaming pipeline and
Mhm.
be like, oh, like resize it and create a thumbnail, like tee the stream. I mean, there's so many cool things you can do with the
Yeah.
streams, right? You can tee the stream, and now you've got 2 streams that contain the exact same bytes. Send this one over to S3, send this one off to a little, image thumbnail maker,
Mhm.
and send it off to S3 when it's done, right? Like you can get huge gains in efficiency in your infrastructure if you're streaming
Yeah.
stuff.
Just in case people watching the stream are thinking as small as I have about this, I wanted to expand their minds a little bit as mine has been expanded.
Yeah, it's cool stuff. So check out this. This is how you work with basically Node. Node has had their own concept of readable and writable streams for a long time now. And so you can just fs create write stream, and similar to what we were doing on Bun, I created a little async generator in this case, but yeah, you just, as the chunks come flying off the stream, write them to the file stream. Interesting side note here, file stream.write needs a buffer object. If you've worked with Node, you'll be familiar with the buffer objects. Buffer is a subclass of uint8 array, which is what this thing gives you. So like, it's totally fine working with uint8 arrays, which are basically just like these binary data buffers. They're these views into these buffers. So yeah.
Kind of like what everything on a computer is made out of, basically.
Yeah, exactly. Bytes. So why is this, why is this cool? So, we've said for a long time, oh yeah, Remix is just going to run anywhere that JavaScript runs.
Mm-hmm.
Right. So literally all of the stuff that we're making is, especially low level pieces like this are going to ship with demos of how you can use this exactly, like working demos of how you can use this on all the different JavaScript runtimes. The cool thing is that when you build in a kind of a generic way like this, using just the web's kind of built-in primitives, and this is something that I really, really want to debunk. This is like a myth that I want to debunk, and that is that the web primitives are slow, or that web streams are somehow slow.
Yeah.
Like they might, in case Jared Sumner or Ryan Dahl or somebody, who really knows about performance is listening to me right now, they might be slower. They might be suboptimal in some cases. Let me just say that. They might not be the most optimal thing in the entire world, but they are not slow. Like they can actually be quite fast and totally reasonable to deal with. So I made a just a silly little benchmark, and I should preface this by saying, like, I don't place a ton of like emphasis on the benchmarks. The only reason the benchmarks are here is to combat that narrative about, oh, web streams are slow and everything has to be slow,
and to prove it to yourself, right? Like that's the bias going in building this, was like, this is probably going to be too slow, but
yeah, well, yes,
exactly.
Yeah. To prove it to myself, because I was like, I don't want to make a slow freaking multi-part parser, and then because people are going to try and use it, and then they're going to come out the gate and they're going to be like, well, this thing's slow and it sucks.
Yeah.
And like, why would I use that? And I'll be like, oh, but it's good because you're using web primitives. Like that doesn't fly.
Yeah, that doesn't fly if the performance isn't good enough. But
yeah, exactly.
So yeah, these benchmarks are critical for the thing to be useful. They have to prove something, but it's not going to be the tagline of the library of like,
this is the fastest thing ever. Yeah, exactly.
Yeah, that's not the main selling point.
Yeah. So I did run some benchmarks. So on Node.js, so my baseline was Busboy. Busboy is it's the library that I've used a bunch in the past.
Downloads a week.
It's a great library. It's a lot of people use it. I have a ton of respect for the authors of that library. Like I said, it's been around for like a decade or more. It's been an awesome library. They're actually using Busboy in some of the demos for Flight for React.
Yeah,
Flight. So it's a very widely used parser.
In the ESM rendered a pipeable stream. Like it's actually in the React source code.
Oh yeah.
It's not just in the demo. It's like it's in the React source code for some of those.
Oh yeah, totally. Yeah. Oh yeah, no, you're right. Yeah, it's not just in the demos. Yeah, they're relying on it. So maybe we can like throw this over the wall.
I think in the React server ESM package, I think, is the one that has that.
Yeah, in fact, a lot of the React stuff relies on the node streaming format.
Yeah, the pipe and all that kind of stuff.
Yeah. The pipeable stream and all that stuff is like node streams. Yeah. So anyway,
so again, that's why we're with Remix, we're focusing on these super low level things, because like our goal is use the web primitives, and at the moment React doesn't do that well enough for us. And so
I want it to run in more places than just Node.
Yeah.
Right. Like I want to run my app, like literally just run my app. Cloudflare Workers is my backend.
Yeah.
Right. Like when you say that, when you say Cloudflare Workers is my backend, that means there is no Node server here. I'm doing everything in an environment, in a backend environment that is not Node. So I can, and they've got like this Node.js compat mode that so you can bring Node specific libraries and try and run them on Cloudflare. But if you'll notice, I commented that thing out in my Cloudflare Workers demo. We don't need Node.js compat mode. Okay, you need Node.js compat mode when you're bringing libraries that were built for Node. This is not a library that was built for Node, although it has great performance on Node. So I just want
it's on like sorry, this is a little bit meta, but like it's almost like everywhere you turn to like really try to start doing more interesting things on the back end in JavaScript, you bump into Node, obviously, because
totally, it's the king. It's been there for a long time.
Rhino, Lost, Spider, like Node is the king. But like, so we really want to take Remix even farther onto the back end, and React itself is going farther on the back end, but we keep bumping into Node everywhere. And we thought that one thing in React didn't rely on Node stuff, and then there was Busboy. And so this is about like breaking down that Node wall, and so that we can put Remix anywhere.
And a lot of this is going to a lot of this is going to make it like back into React. I think at some point, like, because I don't know, it'll be an interesting conversation to have.
Yeah.
But I just kind of want to wrap this up. Like, multipart-parser has really great performance on. So I was benchmarking against Busboy, and then I found these guys, Fastify Busboy. And they really put some like jet fuel into Busboy. Like they optimized it big time for Node, and they got really, really fast. And multipart-parser is totally on par with those guys. It's totally on par with Fastify Busboy, which is, I think, pretty cool for a library that's just like,
it's awesome.
I just made it last month, right? Like that, for me, Busboy was like the king of in speed of multipart parsing. And multipart-parser is already as fast as I think the heavyweights on Node. Where it gets kind of interesting though is when you do turn to these other runtimes. So let's check out Bun. By the way, I can't sing Bun's praises highly enough. Like, they are doing a really fantastic job over there.
That's awesome.
I had a lot of fun with it. But Bun is actually it's not V8. It's not Chrome V8. Bun is WebKit. It's JavaScript engine. I think they call it JavaScript core. And it is fast.
Yeah.
This thing is so fast. So this is 8.31 milliseconds on average to upload 3 10 megabyte files, 1 20 megabyte file, and 1 50 megabyte file. So 5 large files. That's this benchmark. Is 5 files, 3 10s, 120, and 150 in 8 milliseconds. So like, you're just flying. You're just flying through the stream and just. Yeah. I mean, it's
the variance is tiny on that. Look at that.
Very low
compared to the other one's variances.
Yeah. It's like this, and it's almost always that.
Yeah,
like it's just incredible. It's so good on Bun. I love it. And then Dino is also great as well. Dino numbers look very similar to the Node numbers, I think, because Dino is also V8. Except for this number here, this small files benchmark is quite a bit faster on Dino. And I'm not sure exactly the reason for that. But multipart parser just sings on these other runtimes, which I think is for me proof enough that like, okay, I can use this, right? This thing is nice and fast.
Yeah, totally.
And I can totally use it on these other runtimes. So,
and even though it beat everybody in these benchmarks, still not going to be the tagline.
Yeah, no, like I said, it's a silly benchmark. Like it's
what's weird
because this changes, you know, these benchmarks change if I open up YouTube and start like listening to some music, right? Because all of a sudden now my computer's doing more work and all this thing, you know. So benchmarking is it's an imprecise science at best.
Yeah, it's just a smoke test is what I'm looking for.
Exactly. Yeah. So I'm not going to hang on the sign and be like, this is the fastest you can possibly be, because it's just not true. Somebody's going to come along and beat these numbers. Somebody probably already does beat these numbers on certain platforms and certain scenarios. And so it's fine. I just want to know that I am like in the same neighborhood as those guys.
Yeah.
And I get to use this nice web API, which, you know, is which I love, right? I get to use this API, the request API, and then I get to use this multipart-part API.
Not just the request API, but you're just using JavaScript language features here to await those parts instead of like some callback API that you made up or something else, right? Like you're getting to just use not just web primitives, but language features instead of like an event emitter on end and stuff like that, right?
Yeah, that's actually a good point. That's actually a good point. Like what? Yeah. There's no event emitter here. There's no on error. There's no on file or whatever. It's literally just parse this stream and give me the stuff, and then here's your on error right here.
Yep. Or the loader, right? Or don't even try catch. Remix is catching those errors too for you to display something to the user.
Yeah.
So that's why it's really cool to use just the language feature, because if it was if we had our own API here, some on error or something like that, you would then have to say on line 17, you would have to be like, you'd have to throw whatever that on error thing was. Like, oh man, how do I say this? So the naive code with no try catch.
Yeah.
If we get rid of the try catch, the naive code is still going to raise that error up to remix, which is then going to render the error boundary to the user and to the developer.
Yeah.
Where if we came up with our own non-language feature API here, like a event emitter or something, we're going to have to add the handler, and then we're going to have to throw it to the loader.
Totally.
It's so good when
language features, relying on language features is so much more powerful than like, let me invent my own event emitter callback API or whatever and give that to you, right?
Yeah, the mistakes get minimized so much when you do that.
Yeah. So yeah, that's a cool little library that we're going to be using for multipart parsing. Again, like the headers library that I talked about a while ago. You can use this literally today. Like we don't need to ship a new version of Remix or ship anything more than what we've already used. Like you can use this right now. And I've got working demos here and everything that you can use in this multipart parser. So this is kind of like, these two libraries are kind of a taste of what you can expect to see from us on kind of the back end of things. And kind of helping this web fetch ecosystem kind of mature on the back end. And then hopefully some of this stuff will make it back into React itself as well, right? Like multipart handling, for example, I think should be, their
actions just give you form data of, okay, now what?
Yeah, exactly. Exactly. Yeah. So next up, I think for me is one of the things that I would like to work on next is like an actual streaming form data solution complete with like a storage API. So you can literally just say, my storage is R2, parse the request, any files that you find, put them in the storage.
Put it over here.
My storage is S3. Go and parse the request, and anything that you find, put it over there, and maybe like a little translation layer in between or something. But yeah, request.form data is Unfortunately,
it's insufficient.
Unfortunately, it's kind of a dead end because there is no storage API that you can sort of shoe in here. But anyway, that's TBD on
and
exactly what that API is going to look like.
Yeah, and it's going to be tricky for us in Remix because of the way server actions are just like you get the form data already buffered and everything's in there.
Yeah, that's garbage.
So we're gonna. It's impossible for us to
I said that
implement.
on the live stream. I shouldn't have said that.
Yeah, it is. Well, it's naive. It's
yeah. It's early days, I guess, is what we'd say, right? Like,
yeah,
it's one of those problems that you're working on more important problems. You're frying bigger fish, so you're like, I don't know what we're gonna do with this multi-part. Just buffer it for now. Like, let's get on with the meat of this problem, right? Which is kind of the more interesting thing that you want to work on.
I guess all I'm trying to say is it's unlikely that the Remix use server abstraction is going to work exactly the same as it does in Next.js, because we want access to this lower level response body so that you can do this kind of stuff.
Yeah, totally.
And or we're going to have to do something weird with form data that's kind of non-standard. Like, okay, here's the parts.
yeah.
But yeah, so the anyway, that's all, and that's fine. Like you said, it's early days.
Yeah, it's early days. Yeah. So anyway, I've gone a half an hour over.
I enjoyed it.
I apologize for anybody who was time boxing this, but that's what we've got. So yeah, what we're trying to do, I guess, is just, release some software. Like I said, I don't expect people to put Remix in their, solid start. I don't expect the folks building solid start to put Remix in their dependencies, right? I don't expect the folks building SvelteKit to put Remix in their dependencies. But hopefully what we can do is we can chunk off some of these smaller pieces, and and since we're all using sort of the same common level primitives, we can say like, yeah, I can use that. I can use that piece without bringing in all of Remix. And so, yeah, Remix in the end will be kind of like this, this kitchen sink that brings all of this stuff together with like a really nice router and a really nice developer experience. But in the meantime, like you can already use this stuff.
Yeah, I think it's going to be a router plus a whole bunch of packages for backend things like the things you just showed us, and front end things in React, and then mostly it's a doc site after that.
Totally, yeah.
How to bring them all together. The philosophy.
Yeah, and make sure we surface the right TypeScript types for you, and then it just documents itself.
Yeah, and then and I guess one last thing, since someone just mentioned React Router v7, that's going to support server components too, and so like we don't want you bringing in Remix at v5 or whatever in your React Router v7. Like, that's all weird, but like you do want this headers abstraction, and you do want to be able to parse form data in these ways, and so these other packages are going to be used across both of them, so that when you move from a React Router v7 to a Remix v48, that code mostly just stays intact, and your dependencies mostly stay intact. Yeah, it'll be good.
How many people caught the v48 that you just dropped?
It's going to be 33, 48, or no, 33, 45, or 78.
Yeah, I always forget the numbers.
It's going to be one of those.
All right, thanks everybody for hanging with us today, and hopefully, we gave you some cool stuff to experiment with and work on, and